Hello students, in lecture 10 we shall discuss some important terms that we come across in AC circuits. Those are active power, reactive power and apparent power, the difference between active and reactive power, the impedance and power triangle and power factor. So the first power, active power or real power or average power or true power. The power which is consumed in an AC circuit is known as the active power. It is measured in watts or kilowatts, and active power is usually denoted by capital letter P. If V and I are the RMS values of voltage and current, and cos phi is the power factor, then active power is given by the equation Vi cos phi. An active power in an AC circuit is a power that is consumed in resistance only. We have already learned in the previous lectures that in pure inductive and pure capacitive circuits there is no power consumption. So the power usage happens only for resistive networks. So we may write the equation for power as I square R watts also. An active power is the actual outcome of electrical system which runs the electric circuits or loads. The second power is the reactive power or wattless power. The reactive power is the power that is being spent across the inductive reactance or the capacitive reactance. The reactive power, it moves between the source and load of the circuit. This power is not doing any useful work as the active power. So that's why it is termed as a wattless power. Capital Q is used to represent the reactive power, and its unit is VAR, which means volt ampere reactive. So Q is equal to VI sin phi. Just in the beginning was said, the reactive power, it is a power that is expended across the reactance. So you may write the equation as I square X VAR. The X is the reactance component, which could be XL or XC, inductive reactance or capacitive reactance. A pure inductor or a pure capacitor, they do not consume any power. Whatever power is received from the source by these components, the same power is returned to the source. This power which returns and flows in both the direction is known as this reactive power. Next comes the apparent power or total power. In an AC circuit, the product of root mean square values of voltage and current is known as the apparent power. This is the total power of an AC circuit. It is represented by letter capital S, and the unit is VA, which means volt ampere or kVA, kilovolt ampere. So you may write the equation for total power S is equal to VRMS into IRMS. Now the difference between the active and apparent power. Active power, as I said, it is a power that is being utilized or dissipated in a circuit. Whereas the reactive power is a wattless power which moves back and forth between the load and source. The equation for active power is P is equal to VI cos phi, and the equation for reactive power is Q is equal to VI sin phi. The unit of active power is watts, whereas the unit of reactive power is volt ampere reactive. The measuring instrument that is used to measure active power is known as wattmeter, whereas VAR meter is used to measure reactive power. The active power, it produces heat in the heater, light in the lamps and torque in the motor. Whereas reactive power, it measures the power factor of the circuit. Now let's see what is a power triangle. So as I have already said about the three powers, the apparent power, real power and reactive power. Apparent power is the total power. So in the power triangle, the apparent power will be occupying the hypotenuse portion. Now, the real power, which is P is equal to VI cos phi, that will be the cosine component if an angle phi is made in this right angle triangle. Real power is the power that is being expended across the resistance only. Whereas the reactive power Q, which is equal to VI sin phi, it could be either in the positive upward direction or the negative downward direction. It is positive upward direction if the reactance is inductive reactance XL. Now this figure, it actually shows the power triangle exclusively for an inductive reactance. If it was a capacitive reactance, then this right angle triangle would be facing towards down. So the reactive component of power is VI sin phi. You can see in the equation S is equal to square root of P square plus Q square. That is, hypotenuse is equal to square root of cosine term square plus the sine square term, opposite side square plus base square. In terms of unit, kVA is equal to square root of kW square plus kVAR square, or in equation you may write that VI is equal to VI cos phi the whole square plus VI sin phi the whole square. If you bring the VI term outside, cos square phi plus sin square phi, it will be yielding 1. That is how you get the total power. This power triangle is a representation of a right angle triangle that shows the relation between the active power, reactive power and apparent power. When each component of the current, that is the active component which is I cos phi, or the reactive component that is I sin phi, is multiplied by the voltage V, then a power triangle is obtained. Next is impedance triangle. An impedance triangle you can easily derive from a voltage triangle. This is also a right angle triangle in which the hypotenuse portion, it is the voltage of the entire circuit. That is the voltage across the impedance. V is equal to IZ. If an angle phi is made, then the base VR, that is the voltage across the resistor, will be equal to IR. And the opposite phase, that is VL, the voltage across the inductive reactance. If it is capacitive reactance, then this right angle triangle will be inverted. So you should write it as VC is equal to IXC, because there the current will be lagging the voltage and here the current is leading the voltage. Now if you remove that common factor I from the voltage triangle, you will get the impedance triangle, where the impedance Z will be the hypotenuse, R and X, its cosine and sine component. So Z square will be equal to R square plus JX square. The X, it could be either XL or XC. the unit of impedance is ohm. From this figure, you can derive all the angle. If you take cos phi, you get R by Z. If you want to find sin or tan, you get it as X by Z or X by R. Now here, these angle calculations are important while you are doing problems. The impedance, it is a vector sum of resistance and reactance. Just like the total power, the apparent power was the vector sum of active power and reactive power. The impedance, it not only has a magnitude but it also has a phase angle phi, which represents the phase difference between the resistance and the reactance. Now the shape of the triangle, as said, it will vary depending upon the reactance. If it is XL, it will be like the figure that is shown. If it is XC, the capacitive reactance, then the impedance triangle will be inverted. Whereas the resistance, it will be remaining always constant. Next is power factor in an AC circuit. A power factor which is denoted by cos phi is a very important part of an AC circuit that can also be expressed in terms of circuit impedance or power. In terms of power, the power factor is defined as the ratio of real power to apparent power. It is generally expressed as a decimal value or percentage. Or another definition for power factor is the power factor defines the phase angle between the current and voltage waveform, where I and V are the magnitudes of RMS values of voltage and current. In terms of power, power factor PF or cos phi is equal to active power divided by apparent power. That is, unit is watts per volt ampere or P by S, or VI cos phi divided by VI. So VI get cancelled, you get power factor cos phi in terms of power. In a pure resistive circuit, the current and voltage waveforms are in phase. So the real power consumed is same as the apparent power, as there is no phase difference. So the power factor will be cos 0, which is 1. This implies that the number of watts consumed in the same as the number of volt ampere consumed, producing the power factor of 1 or 100%. In this case, it is referred as unity power factor. That is why we usually say is that for a resistive network, the power factor is unity. Now for reactive circuit, that is purely inductive or purely capacitive, the current and voltage waveforms are out of phase with each other by 90 degree. Therefore, the phase difference cos phi, it will be cos 90, that is equal to 0. So that is the number of watts consumed is 0. But still there is a voltage and current supplying this reactive load. You may write the cos phi or power factor in terms of resistance and impedance also. That is, cos phi is equal to, from the impedance or voltage triangle, you get it as VR by V. VR is equal to IR and total voltage V is equal to IZ. So cancel out the I, you get R by Z.